Okay, here we're going to simplify another trigonometric expression. Now remember that a lot of times the problems that are assigned in your book are the odd problems. So if you get really stuck on something, you've tried things, it's just not working out, you might try just looking at the answer to see if that can help guide where you're going a little bit. So we see on this one, it's not a nice clean answer necessarily. But there is a good indication of what we should do on this one, because right away we see that we have two fractions being subtracted. Most of the time when you see that, you're going to want to get a common denominator and add or subtract those fractions. So here the common denominator, we see that they are actually conjugates, 1 minus secant x and 1 plus secant x. So we're going to multiply each side by the other denominator. So we're going to have the secant of x times 1 plus secant x minus the secant of x times 1 minus secant x. And all of that's over 1 minus secant x times 1 plus secant x, which we should recognize as being an a minus b times a plus b. So that is 1 minus the secant squared of x. Okay, so next step here, we probably want to take this and distribute. So if we distribute, we get secant x plus secant squared x minus secant x plus secant squared x, watch your signs there, over 1 minus secant squared x. Well, that 1 minus secant squared x, I'm thinking there's something up with that, because I remember seeing an identity involving a 1 and a secant squared. I don't remember exactly what it is. So I'm going to go back to my basic Pythagorean identity of sine squared of x plus cosine squared of x equals 1. Knowing that I want a secant squared in this, and secant is 1 over cosine, I'm going to divide everything by cosine squared. And that's going to give me tangent squared x plus 1 equals secant squared x. Oh, and if I rearrange that, I have that tangent squared x is secant squared x minus 1. Well, that's not quite what I wanted. I wanted 1 minus secant squared x. But remember that when we have a subtraction that we want to switch around, we can always factor out a negative 1. So I can write that as negative 1 minus secant squared of x. Okay, to give me a little more room down here, I'm going to get rid of this stuff. So that's something I might have done on scrap paper just off to the side somewhere to help remind myself. So the secant, I wrote something wrong up here. This should be a plain secant x here, not a secant squared with no x. So at this point, we see that the secant x's are going to drop out, and we're going to have 2 secant squared x over the opposite of tangent squared x. Not looking like we're heading toward the answer that they had there, but it's looking like a pretty nice answer. So maybe we're going to come up with something better. Well, secant squared is 1 over cosine squared. So we have 2 over cosine squared x. And tangent, I'm going to take the negative from the tangent and just put it in front of the whole fraction there. Tangent is sine over cosine. Since it's in the denominator, I can write that as cosine squared x over sine squared x, and cancel the cosine squareds, and I get negative 2 over sine squared, or negative 2 cosecant squared x. A lot nicer looking result than what they had here. Okay, try getting a common denominator and doing the addition to simplify the next problem. And the answer is D, 2 cosecant x.